and afterwards we make it more like deeper. Okay, so we have the original hole, and then we have like this, and you can see that if we see this from the side, okay, if it was three-dimensional, I'm showing you here this hole that we made, but really it's three-dimensional. So this would become this, okay? We can go from here to here, and eventually all the way to a shape, to a cup shape. Or in the other direction, we can go, we can take the cup, okay, and fill it with clay, with ceramics, okay, the stuff that it is made from, and we fill it. So there is no more valley here, okay, there is no more dent in here. It is flat, okay, it is filled with the material, and then we will be left only with one, only with, like, this would be a full shape, and the hole would still be here. So we can go also in the other direction, from here to here, from a cup to a donut, if we fill the shape here and make it smaller, okay? If we take this shape and fill it so it is all made with this material, the same material that is here, okay? I'm just making this red, and this also red, so that you understand. Okay? So if we filled this whole shape with material, and we are left with the hole, and we make it smaller, we said we can stretch in topology and we can squeeze, and it's okay as long as we don't make holes or we don't cut a line. So eventually we can compress this shape and push it without making holes, and until we are left with a donut. Okay? So you can see it's the same shape. The cup and the donut, from topology's point of view, are the same shape. Okay? Because they both have one hole. And this is what is important. Okay, so this was figure 2. And now let's see something else. I'll erase this. Okay, so another point is that if we have we said that we cannot cut a line, but it's, let's say it's more like to be exact, to say it in a more correct way, would be that in the beginning and in the end, it should have the same connectedness. It should have the same order of points on it. Okay? For example, if we have the small bug, remember we had the small bug that walked. Okay? Okay, remember the small bug. And if it encountered, if it came to a line that looks like this. Okay? And it's walking on the line, and this is like 0.1, 0.2, 0.3, 0.4, okay, so it knows the order of the points on the line, and the line is connected. And if we have another line, okay, I know it doesn't look like a line, but remember the equator in topology, this is a line, okay? So it's not straight, but this is called a line, because we don't care if we bend the shape or stretch it or squeeze it, it's okay, or we twist it, it's okay as long as we don't cut it and leave it like this. If we cut it, we have to connect it again, and it should be in the same order. What do I mean? Until now we said we cannot cut it at all, but now I'm making it more precise, more exact. We can cut it, it's okay, but we need to connect it afterwards. At the end it should be connected and the points should be in the same order. Now I'm showing you how. If we took this line and imagine that this is a rope, okay? This is a piece of string or a rope. You can tie it, you can make a knot. Okay, let's make a knot. Okay, like we do with the shoelaces, we tie a knot. If we take the same line, okay? Okay, I hope you understand. We took this line, we disconnected it, we made a knot, okay? And we tied it again. Let's say if I have this. Okay, this is a USB cable. Okay, I use it for my graphic board. And this is this one, okay? This is the string. And if we take it and make a knot, okay? We tie a knot. And connect it again. Okay, it's hard for me to hold it so that you will see that it is supposed to be the same, but it's something like this. Okay? So you understand, it is the same line with the points on it. If we put small markers here, this is 1, this is 2, this is 3, and the bug would walk on this line, and he will know the order of the nodes in clockwise in this direction, and he will walk here along the line,